Welcome to Brain Vision.
Okay, so we're in chapter 37, problem 46. So it says neutrons can be used in diffraction experiments to probe the lattice structure of crystalline solids. Since the neutron's wavelength needs to be on the order of spacing between the atoms in the lattice, which is about 0.3 nanometers, what should the speed of neutrons be? Okay, so we can assume that it's not relativistic, and if the resulting velocity is very small, then our assumption is going to be valid. If it's pretty close to c, then we might need to go back and assume it's relativistic and redo our calculation. But assuming it's relativistic, we can use equation 37(7) like we had before, and we know that the wavelength is h over p, and with the non-relativistic approximation, p is just mv. So now we know that v can be written as h over m lambda. So we can just plug this in. H is 6.63 times 10 to the negative 34 joule seconds. Mass of a neutron is 1.67 times 10 to the negative 27 kilograms. And it says the wavelength to use was 0.3 nanometers. Cool. So this is all in SI units, and we see this comes out to be roughly about 1,300 meters per second. So this is very far away from being relativistic, so we know our approximation is good, and this is probably the speed needed to be used.